Hi everyone. Today I'm going to give you an introduction to the buffers and Hi everyone. Today I'm going to give you an introduction to the buffers and buffer capacity lab experiment. This is a 1-week lab. It's going to follow a worksheet, sort of a guided inquiry type of lab experiment. Make sure you print that worksheet. It's really important that you bring it with you. If you don't and I need to print it, it's going to cost you a few lab etiquette points. This lab we're going to work in groups of 4. Okay, so make sure you're working in groups of 4. The experiment has been designed for groups of 4, and it's a lot easier to get everything done if you're working in that size group. So there's 5 different parts to this experiment, and I want you to be able to complete all of these in lab. Okay, the first 3 parts 1 through 3, you're going to be making different solutions of buffer. And you're going to be measuring their buffer capacities. Now there's 2 different types of buffers we're going to be making in lab. There's an acetic acid acetate buffer, and there's a tris buffer. And depending on which group you have, you're going to have one or the other. One of the ways in which you're going to prepare a buffer is by mixing already made solutions of acetic acid and acetate, sodium acetate, or tris acid and tris base to prepare a buffer. And you're just going to try different ratios. Another way is by using a solid salt and mixing that with a pre-made solution of the acid version of the buffer, so either acetic acid or the tris HCl. In any case, you're going to end up measuring the buffer capacity for each of those buffers. And the buffer capacity is a really nice measurement because it gives you a sense of how well the buffer works. Something with a high buffer capacity will be a better buffer, a buffering against changes in pH. There's a couple of different ways you can measure the buffer capacity, and you're going to be doing those. And by different ways, I mean you can either add HCl, strong acid, or you can add strong base, in this case, sodium hydroxide. And so the way we measure the buffer capacity is by determining the moles of either acid or base, strong acid or base, that we've added to our buffer, and looking at the pH change that takes place. And we need to know also the volume of buffer in liters so that we can determine the buffer capacity. So what you're going to do is take your buffer, you're going to put it in a beaker. You're going to add a pH electrode and measure the pH. And you're going to set this all up under a burette where you can add either the strong acid or strong base, and you can know the volume of strong acid or strong base that you've added to your buffer mixture. Now, you want to be able to change the pH enough so that this is a useful equation. So usually that's around 0.5 to 1 pH unit. Now it's possible that your buffer will break down, meaning it will no longer be a buffer when you've added enough acid or base. So if you get to that point, you're going to need to remake the buffer and remeasure the buffer capacity. But about a pH change of about 0.5, you should be okay. So you're using the burette because you need to know the volume added to make that pH change occur. So make sure you write down your volumes. You need to know your pH change, and that's just going to be in pH units, whatever it may be. So write down your starting pH and your ending pH. And the volume of the buffer in liters. So if you add 15 milliliters of buffer to the beaker, that's going to go 0.05 liters. Okay. So that's parts 1 through 3. There's different variations of the things you're going to be trying, different ways of making the buffer, and you're going to see how that affects the buffer capacity. In parts 4 and 5, this is a more theoretical look at buffers. We're going to be looking at polyprotic buffers and thinking about the ways that they change how the calculations are done, basically. We're also going to take into consideration the ionic strength for each solution that we would theoretically be making, and then in addition to that, the activity. So ionic strength, I don't think I spelled that right, which is mu, and the activity, which is gamma. So each ion in solution is going to have an activity associated with it. If it's not an ion, it doesn't have an activity. Okay? There are two different ways of determining the activity for an ion in solution. We've got the Debye-Huckel equation, and we've got the Davies equation. These are explained in your handout, but you use these at different times based on the ionic strength of the solution. So if the ionic strength of your solution is less than 0.1 molar, then you can use the Debye-Huckel equation. If the ionic strength is between 0.1 molar and 0.5 molar, then you need to use the Davies equation. Okay? Those just, they account for things in different ways. The only thing you're going to need to turn in for this experiment is the buffer worksheet.